All right, guys. So this video is meant to be just a really quick summary of the GDP deflator, the Consumer Price Index, or CPI, and how you would use both of those to help you calculate inflation. So as a quick reminder, calculating inflation is really just calculating a rate of change, and we're calculating the rate of change of prices over time in the economy. But the biggest problem is, how do we come up with a single number that represents the price of everything in the economy at a given time? And so there are two options here, and either option then gets plugged into the same rate of change equation. So the first option is the GDP deflator, and the GDP deflator is simply nominal GDP divided by real GDP for whichever year you're using and multiplied by 100. And because this GDP deflator is an index, in the base year, the GDP deflator will always be 100, because in the base year we know the nominal GDP and the real GDP will be the same. So dividing a number by itself will give us 1 times 100 gives us that in the base year the GDP deflator is always 100. The consumer price index, if you remember from the last video, is not quite the same as the GDP deflator. Instead of using all of the goods in the economy and using, instead of using all of the goods in the economy the way the GDP deflator does, the consumer price index only uses a specific basket of goods. But in essence, the consumer price index really follows the same equation. We take the cost of the basket in the year you're working with, which we will call the current year or the given year. So the cost of the basket in current prices, and you divide that by the cost of the basket in the base year. And then that whole thing again gets multiplied by 100. And in the base year, the CPI is also always 100, because if the current year and the base year are the same, then dividing the current year price by the base year price will get you 1. 1 times 100 will always be 100. In either case, we wind up with a number that we call an indexed number. And that indexed number is what we put into our inflation rate equation. So we take index from the newer value minus index from the older value, and we divide that whole number by index from the older value. And that is our basic rate of change equation in the first place. Right? So either the deflator or the CPI can be plugged into our rate of change equation, because both of these numbers, the deflator and the CPI, are really just a stand-in for the price level in a given time, or at a given time in the economy. One other way to look at this, and one helpful way to look at this, is to go back to thinking about our nerd triangle. And when we think about our nerd triangle, you actually can use the nerd triangle for both of these. So just as a quick review, on one side we have our nerd triangle for the GDP deflator. And the nerd triangle reminds you that nominal divided by real is always equal to the deflator. And as a reminder here, if you cover up whichever variable you want to find, it will give you the equation for the other variable. So if we cover up the nominal GDP, we would be left with real times deflator equals nominal GDP. If we cover up the deflator, we get nominal divided by real equals the deflator. You can do a similar process with the CPI, and we can actually kind of use the letters CPI to help us remember this relationship. We can take the current price, and we can divide the current price by the price in the base year, and that will give us our index, which is the CPI. So current prices divided by base year prices always give us our index. And just as a reminder, that really is the exact same thing that's happening in our GDP deflator. Nominal GDP always uses current prices, and real GDP always uses base year prices. So even though the values here are going to be slightly different, nominal over real and current over base are the same idea. But the biggest thing you need to know is that when calculating inflation, there are two different price index values that we could use. One is the GDP deflator and one is the consumer price index, and that both of them will eventually get plugged into the same rate of change equation to calculate inflation. Hope that helps. Get some practice problems done and send questions my direction.